3 different pairs of shoes are placed in a row so that no left shoe is next to a right shoe from a different pair. In how many ways can these 6 shoes be lined up? So let's let our shoes be A1, A2, B1, B2, C1, and C2, where A1 is a left shoe, so that's left. A2 is a right shoe, and these are from the same pair. So these guys are from the same pair, so are these guys, and so are these guys. And A1 cannot go next to B2 because that's a left shoe next to a right shoe from a different pair. And it cannot go next to C2 either. However, it can go next to A2, which is right shoe from the same pair, or B1 and C1, which are left shoes from other pairs. So let's see how we can visualize this, because it's always a good idea to visualize something when you have limited options. So you have a point A1 here, and then you can go inside different directions. You can either go this way, or this way. And then one way gives you B1, another C1, and another A2. And it seems like left shoes are really different from right shoes. So we might want to consider the A1, B1, C1 to be separate from the A2, B2, C2. So which means that we can put the other ones here. So that is B2 and C2. And then we can connect them all by edges. So now we have our triangular prism here, and we want to find out the number of paths from A1 or any vertex to another vertex, such that it goes through all these vertices. So without less of generality, let's start our path at A1. So this is the start of our path. Then we can multiply our answer by 6 to account for where we start. So if we start at A1, there are 3 options where we can go. The first is if we go down. The second is when we go this way. And the third is when we go this way. So let's start by going down. That's our first case. And we're going to add a case count here. So if we go down, there are 2 options where we can go, which are equivalent by symmetry. Either we go this way, or we go this way. So let's go this way. Then once again, we have 2 options where we go. Either we go like left, up, right, or we go up, left, down. And we basically have to go inside a cycle, and that cycle can be clockwise or counterclockwise. So that gives 2 ways for if we go that way, and then 2 ways for if we go this way. So that gives 2 plus 2, which is 4. So let's put that here. So the second case, let me go ahead and put that here. The second case is if we go this way. And the third case is similar to the second case because it's just symmetry. Then there are 2 ways where we can go from here. Either we go this way or we go this way down here. So if we go this way here, in the end, we are forced to go down because we do not want to get to the same vertex. So we go down, and then we can either get to these other vertices here by going this way or going this way. So that gives 2 ways. So 2 plus 1. So, and if we go down instead, then we are forced to either go to A2 or B2. If we go to B2, then we either go to A2, which will isolate us from B1, or we go up to B1, which will isolate us from A2. So that can't work. Thus, we're supposed to go this way, then this way, than this way. Thus, there are 2 plus 1 equals 3 ways in the case where we move on the top face. So that's 3, and then we also get 3 for the third case where we move to B1 instead on our first move. And summing it up, we got 4 plus 3, which is 10, so it's 6 times 10, which is 60. Answer choice A. Thank you so much for watching this video. Please subscribe if you'd like to see more.